So before we start talking about the four-stroke engine in detail and how it works, let me just introduce you to a four-stroke engine timing diagram. Now this diagram represents the crank angle, that is the angle of rotation of the crankshaft. We've got the TDC, which is top dead center, and BDC, which is bottom dead center. The piston moves up and down as we go around, or as the crank is rotated in a clockwise direction. So keep that in mind. This round space here would be the crankshaft. So we have angular motion, that is to say the crankshaft rotates in a clockwise direction, whereas the piston moves up and down towards top dead center and then back down again. IO means inlet open, and IC means inlet closed, EC means exhaust closed, and EO means exhaust open. So we're talking about the air inlet, which is blue. Blue represents air, and the exhaust, hot exhaust gases, which are represented by the red EC and EO. What they're specifically pointing to along this line, or along all of these four lines, are the exact points where the valves open and close. So air inlet valve opens at the exact point here where the line is, and the air inlet valve closes again where the line is here. But let me show you how you can read the diagram. So let's imagine that we've just finished a combustion cycle and we need to draw fresh air into the cylinder. So our piston's going to come towards top dead center. You can see it's rotating around, the crankshaft rotates around, the piston's being pushed upwards, and then at this point here, the air inlet valve is going to open. It's then going to draw air in as the piston moves down and the crankshaft rotates clockwise. Piston reaches bottom dead center, comes around here, so we're looking at about 200 degrees. The straight line vertical here is 0, so 180 to the lower straight line, and about 200 or 210 here. So the air inlet valve is open, closed. Okay, so at 210 degrees, the air inlet valve has closed. So now we can see we've ended on IC. Now we're going to continue rotating around, but because we've drawn in the air, we're now compressing it. As the piston moves up to top dead center, we're going to have this black thick bar going all the way across until about 5 degrees past top dead center. What this is the period where we inject fuel and where we have combustion. So we're getting our controlled explosion in this sort of area here. So the pistons come up, it's almost at top dead center, it's approaching top dead center, we're having our explosion, and then it's going to start coming back down again. So with that in mind, this actually looks quite early. Normally I'd expect it to be about here, maybe 5 degrees before or 10 degrees before top dead center. It looks a lot more on this diagram. But anyway, the point is, we start injecting fuel, we compress the fuel, it ignites, we get our explosion, and then what's going to happen is that this explosion, the increase in pressure, is going to push the piston back down again, down, and then what's going to happen is the exhaust gas valve is going to open, because this whole section here was effectively our power stroke. So we've extracted the power's been transferred to the crankshaft and then to our load. The exhaust gas valve opens, we push out the exhaust gas all the way as the piston comes up to top dead center. So here we're discharging the exhaust gas, pushing it out up to top dead center, and then what we're going to do is start drawing air in around about here, and as the piston comes down again, we're going to draw fresh air in, and the process repeats. So where we're actually drawing fresh air in this section here, and the exhaust gas valves are open, that's effectively the scavenging period where we're going to try and get the exhaust gas out and the fresh air in, and then we'll close the exhaust gas valve here and allow the air to be sucked in as the piston goes downwards, and then we'll get our compression stroke again. So we've got intake, compression, and then injection, combustion, or explosion, controlled explosion in this area, expansion, which is also a power stroke, and once we get out of the power stroke, we're going to have the exhaust, which is this section around here, and then the process repeats. So that's how you read a 4-stroke timing diagram. 2-stroke is a lot more simple because it's literally power stroke around here, have a quick change of valves to get the exhaust gas out and get the air in, and then you're going to compress it, and then you're going to have an explosion, then expansion, and etc. And the whole process repeats. So two-stroke is 360 degrees of operation around the crankshaft because it's 2 strokes, one down and one up. And four-stroke is down, up, down, up. So it's 720 degrees of rotation of the crankshaft. So now that's done, let's have a look at the stages of a 4-stroke combustion cycle in more detail. So next lessons are going to look at things like intake, compression, exhaust, and we're going to explain exactly what's happening. We're going to look at the temperatures and the pressures related at each stage of the combustion cycle, and hopefully you'll get a much deeper understanding of exactly how the engine is working.